Hi, everyone. I'm one of the TAs here. My name is Hudson, and I want to welcome you all to Saturday morning astrophysics at Purdue. I'm currently a sophomore here, and I'm studying aerospace engineering. My main focus in my studies is studying space probes and astrodynamics, but I'm also doing minors in both physics and astronomy. We've got a really awesome presentation this morning, but I want to get started with a couple of questions first. Who remembers ET?
When you say ET, you mean like from the movies?
Yeah, ET from the movies. Okay, yeah. Naomi says he came from an unidentified other planet. That's good. So, who's ever wondered about the possibility of alien life existing somewhere out there in the cosmos? Do you think that life could exist out there in the universe that's as sophisticated as the life here on Earth? What do you think about that possibility? Naomi says yes. Yes. A lot of yeses. Absolutely yes. Okay, yeah, strong answers on that one. Today we have Anirudh Kumar, who will be presenting our program called The Great Filter, Does Life Find a Way? Anirudh, or Ani, is a second-year grad student here at Purdue, and one of his research interests is the possibility of extraterrestrial life and how far that life might advance. So I'm going to hand it over to Ani now, and he's going to get started with this awesome presentation.
Thank you, Hudson, for that lovely introduction. I am super excited to be here and be presenting this really, really interesting topic of the great filter and life beyond Earth. Before I get started, I just want to say that this will be a very open-ended sort of discussion. A lot of the questions that I'm going to be asking here don't really have a right or wrong answer. So please do not hesitate to chime in with questions, comments, anything that you want. Feel free to interrupt me at any time. Student participation is very strongly appreciated and encouraged, so don't be shy. Having said that, I'm going to jump right in to my first question that I want to ask. What do we mean when we say alien? So what is the first thing that comes to mind when you hear this word? Life on other celestial bodies, yeah, okay. Life on other planets, okay. Anyone else want to give it a try? Something from another planet. So yeah, so this is some really great responses, and you're absolutely right. Aliens is basically something, life beyond Earth, right? And a lot of times when we ask people what they think when they hear the word aliens, they may say something like little green men on Mars, or maybe something with gray skin, big eyes, or something that they've seen in their favorite movies or television. While all of those are correct definition of what an alien is, they only represent a small subset of all the aliens that could be out there. So for our discussion, we'll be referring to an alien as any type of life outside of Earth. This could be in the form of small bacteria or alien plants or even very intelligent alien civilizations. So all of these definitions will be classified as aliens. I wanted to at this point, do a quick poll of whether you think life exists outside of Earth. So it seems like we have a very even split between life maybe out there, but not as advanced as life on Earth, and life in multiple levels of intelligence is certain. So yeah, we have a pretty even split. That's really interesting. These are really interesting results. A Fermi question is a type of question that asks for a quick estimate of a quantity that is either really difficult or impossible to determine precisely. For example, if we ask a question of how many piano tuners there are in the city of New York. Now, this is a really difficult question to answer precisely, right? The best we can do is get like an approximate estimate of how many there might be.
If you're unfamiliar, a piano tuner, pianos get out of tune sometimes they're a little bit off key. So a piano tuner would be a professional that comes around, comes to your house, to your location, to fine tune the adjustments on the piano to keep it in tune. So that person is called a piano tuner.
How do you think we can go about trying to get an estimate of how many piano tuners there are in New York City? How many pianos there are in New York City? Yes, that's very good. So if there are, a lot of pianos, then you would expect there to be a lot of piano tuners as well. Whereas on the other hand, if there's only a few pianos in New York City, then the number of piano tuners will also be lower. So yeah, that's a great point at how many pianos there are. And how many people own a piano, yeah? So, even if you have a lot of people who are interested in music, if they're interested in instruments other than a piano and there's only a few pianos, then yeah, that is also a great answer. This is really the kind of way to approach a Fermi question, is that you break it down into how many pianos are electric versus have strings. Yeah, that is a great answer. So you have all of these various factors that kind of influence the final result, right? And really, this is the kind of way to approach a Fermi question, is that you break this down, you break down the main question into multiple smaller questions that are easier or relatively easier to answer. So this is precisely what you will be doing in your first breakout, where you will be trying to answer the question of you'll be trying to answer the Fermi question of how many intelligent alien civilizations exist in our galaxy. So the same way as we approach the piano tuners question, try to identify all the important factors that may influence the result, all right? So Braden, I think we can start with breakout 1.
Does anyone have any ideas about how we could start?
Maybe how many planets are capable of like having life, or yeah.
We also have some responses in the chat, like our definition of what is necessary for life, which is a good question to ask, and how long the planets have been habitable. That's a really good one as well. And we haven't been the only life form that's been primary on the planet throughout all of the history.
Life didn't start originally, and life may perish at some point. So the time element, I like what Mara said, the time element's a good thing to consider.
Oh, we got another one in the chat. How far away are they from the sun? That's a good one.
Yeah, so let's follow up. What difference would that make? How far away, how far or how close they are to the sun? Okay, so in the chat, we have, if they're too close, it'll be too hot. Great. So there's what we sometimes call the Goldilocks zone. So, in American literature, there's Goldilocks and the Three Bears. And the question would be, this soup is too hot, this soup is too cold, this soup is just right. So they're relative to the sun, the planets have to be in that just right temperature. That's a great answer. If a planet would or would not have life, what kind of things about the planet itself would be essential for life as we know it? What would the planet have to have? I see water in the chat. Yeah, thanks, Ashini. Water is one thing. The Earth has something that most of the other planets in our solar system don't have. What is that besides water? What do we have that other planets typically do not? Yeah, Ashini said an atmosphere. Yes, not all planets have atmospheres. So if we think about all the planets, all the possible places where life could exist, we're narrowing down the choices.
In exoplanet research, the type of star has a lot, like it greatly affects the habitable zone.
All right, welcome back, everyone. How was the breakout discussions? I'm really, really interested in hearing all the great ideas that you came up with. If someone is willing to share, please. Yeah, Naomi, go ahead.
Well, we said it would be important to know how many resources there are on the planet that could be used by any organisms. How long have the organisms been there to be able to evolve to be intelligent? And what is the environment like, and would it be habitable to intelligent life? So, like, look, then sort of as part of that, what kind of terrain does it have, and what is the host star like, and how far away from the star is it, and also the size of the planet and the size of the organisms might affect the population, or whether they would be able to develop an intelligent civilization.
All right, yeah, those are some really great points. I hear a lot of how habitable the planet is, and the type of star that the planet is around. So yeah, those are some great points. What about the other group? What did you guys talk about? Anyone else wants to chime in?
I can share from our group discussion if none of the students want to.
Okay, yeah, go ahead.
Okay. So they came up with some really good questions to ask, like how many planets are capable of supporting life? What is what is necessary for life? How long have the planets been habitable? And how far away are they from their sun? And then we talked about the habitable zone around different stars. And then that brought up the question of, does the type of star affect the habitable zone and therefore the possibility of life? And then also things like, is there water? Is there an atmosphere?
Since a lot of similar points that both rooms discussed, so we'll be looking at this in a much more detail in just a moment. So yeah, that was a great breakout. Great job, everyone. Now that we're back, we had this discussion of how we are going to answer this question of how many intelligent alien civilizations there are in our galaxy, and we talked about some of the factors that influence that answer. But why do we really care about this? Why do we care about this question of how many aliens there are in our galaxy? What does it matter? What do you think?
Oh, I think it's just, it'd be nice to find out we're not alone in the universe. It would definitely revolutionize our understanding of our place in it, our purpose in it.
Yeah. We'd like to know if we are the only life. Yeah. So, humans are naturally curious, and oftentimes in science, we don't need a reason beyond just to know if something exists or not. So that is a really valid answer. Anyone else want to try?
Yeah, I'll say that it could help us understand biology. See if there's any life that's based on things that are not carbon. If maybe a lot of life comes from the same source, or it develops differently across different planets.
Yeah, so the discovery of alien life would be, really a really important milestone in the research of astrobiology. And it could help us answer a lot of questions of how life evolved here on Earth itself. So, but I'd like to hear from some of the students now. Why do we care about, how many aliens there are in our galaxy? Yeah, we could be influenced by them. We could learn new things. Exactly. They could be a possible threat to us. Yes, that is certainly a possibility. So if there are aliens out there and if they are intelligent, then they may have access to technologies that, we could never even dream of. So there is certainly a lot to learn from the discovery of, let's say, an intelligent alien civilization. And there certainly could be a threat, We don't really know what their intentions could be or the way they think. So they could be a threat, and it is important for us to know what their intentions are or how they think, basically. So yeah, all these are some really great answers. Remember, we asked the question of how many intelligent aliens there are in our galaxy. Now, obviously, we are not the first people to think about this question. There are a lot of scientists who thought about this before. One of them was a scientist by the name of Frank Drake. He was an American astrophysicist and astrobiologist. An astrophysicist, if you don't know, is someone who uses physics to answer questions relating to space. And an astrobiologist is someone who studies how life forms and evolves on planets other than Earth. So Frank Drake was an astrophysicist and astrobiologist, and he asked this exact same question of how many intelligent aliens there are in our Milky Way galaxy. And he derived an equation for it to give us an estimate of that number. And that equation came to be known as the Drake equation. So as an equation, there's a left-hand side. Drake placed this letter N that represents the number of intelligent alien civilizations in our galaxy. So remember that, because we'll be referring to that later as well. So N is the number of intelligent aliens there are. The next term that Drake came up with was how many stars there are in our galaxy, or the rate at which stars are born. Because obviously, for life to develop, we need an energy source, and stars are the best energy source there is for life. So knowing how many stars there are really helps, influences that decision. So the first factor is how quickly stars are born. But just having stars is not enough, right? We need planets on which life can develop. So the next factor is the fraction of those stars that can host planets. Now, again, even if there are planets, they may not necessarily be habitable, right? Just like all of you discussed during breakouts, life needs certain conditions to grow. So just because there is a planet, it needs to be, how far away it is from the sun, how hot it is, how cold it is. All those things matter as well. So the next factor in the Drake equation is how many of those planets are habitable. Now, it is not a certainty that even if a planet is habitable, that life must develop there, right? It's not 100% certain. There could be a planet which can sustain life, but just doesn't sustain life. So the next factor that Drake came up with is how many of those planets that can support life actually go on to support life in the future. And then just because a life forms on a planet doesn't mean it has to be intelligent. It could be in the form of bacteria. And based on our definitions of intelligence, bacteria don't seem to be very intelligent. So the next factor that Drake thought of would be important is how much of those life evolved to become intelligent. And once a life form becomes intelligent, they start developing technologies that allows them to communicate at a long distance, right? Technologies like radio communication and communication using light. All those factors are important if we want to make contact with aliens, because we can't really make contact with bacteria in any meaningful way, right? So it's important that aliens have the technology to communicate effectively. And then finally, how long can they communicate for? So for example, if an alien civilization, develops radio technologies, but if they are not transmitting for a long period of time, it might be really hard for us to detect them or to make communication. So how long a civilization transmits these radio signals is also a key factor. So all these there are 7 factors that Drake came up with that he thought would be influential in answering the question of how many alien civilizations there are in our galaxy. What could be possibly wrong with the Drake equations? The Drake equation gives a wide range of values, ranging from n, that is n, remember, is the number of alien civilizations in our galaxy. So the Drake equation has a wide range, ranging from n equals 0, that basically means there is no other aliens in our galaxy, to as high as 10 to the 8, that's 8 zeros. So we have this wide range of values, and we don't really know what the right answer is. So, which is why the Drake equation should not be used to get an exact value, because it's not at all accurate. So it should not be used as to get an exact value of n, but what it is useful for is to give us an idea of where we need to focus our research, right? Because let's say if r, we don't really know what the exact value of r is. So we need to spend more time in researching and trying to reduce the uncertainty in this factor. So the Drake equation, the real benefit of the Drake equation is that it sort of guides us in our research in astrobiology. What I really want to focus on for today's session is the low n case. That is, the low n means that there are not a lot of alien civilizations in our galaxy. But what could cause this? What could cause life outside of Earth to be so rare? Any guesses?
Because it is so difficult to find a planet with all the conditions to support life.
Okay, so you're saying that it is hard for planets to be habitable.
Yes.
Okay, yeah, that's a great answer. Rowan, how about you? What do you think?
It might be, depend on the conditions of the planet or moon.
Okay, yeah, so it's a similar point that you raised, that the planets need to be habitable, and maybe there are not a lot of habitable planets. Okay, that's a great answer. Anyone else? Maura?
I think it would also take a really long time for these civilizations to develop and then still be able to like make contact with them.
Yeah, that is a really, really interesting answer. The idea that life takes a long time to evolve and develop, and that maybe we were one of the earliest life there is in our galaxy. So other aliens may not have had enough time to evolve. So that is a great answer. See, there are a couple of chats. It could be that there are aliens, but just not intelligent, civilized ones. Yeah. So, there might be a lot of planets with primitive life form like bacteria, but, it's like I said, it is hard to detect or make contact with bacteria, right? So it might be that there is a lot of life out there, just not intelligent. So yeah, all of you have some really, really great points. And in fact, we're going to be talking about some of these points later in this session. So one of the reasons that there may be very few aliens is the main topic for today's discussion. It's in the title of today's discussion. That is something called the Great Filter. Has anyone ever heard of what the Great Filter is?
Anna, you're really putting us on the spot here. When I think of filter, I think of like a filter, like a sieve that you would maybe put flour through to break it up into, or gravel or sand. You're filtering out rocks. You have holes where certain ones will fall through and other ones get stuck behind. So that's what I think about.
Okay.
When I think about a filter.
Yeah, because that is, what we know of as a filter in our daily life. So that's a good guess. And yeah, I think we have some answers in the chat. Sounds like natural selection. Yeah, another way of narrowing down. So yeah, by the sound of it, it seems like the consensus is that there's this something that, kind of like narrows down what life could be. So yeah, we're gonna, if we, like I said, there's no right or wrong answer. We're gonna be discussing more of the great filter. But in order to do so, in order to really understand what the great filter is, we need to firstly understand how life evolves. So let's look at the evolution of life on Earth, right? Does anyone know how life on Earth started? Single-cell ocean organisms. Yes, that's exactly right. So life began in the water, at least that we know of, as unicellular single-celled organisms, right? What happened next then? Okay, so let's say life started as single-celled organisms. What happened after that? They evolved, yes. Evolved into what form? Did single-cell organisms just evolve into humans, or was it anything else in the middle? They went from single cell to multicellular, exactly right. So single cell organisms, eventually they formed these unions and eventually became multicellular beings, and they became much more complex. Multicellular organisms are much more complex than single cell organisms. And like Sana said, they evolved. And the process of evolution is, where an organism changes drastically in response to their environment, right? If an organism wants to survive, it needs to adapt to its environment. And in the process of this adapting, they undergo these changes, and that's how species evolve. One such change happened for our early ancestor, the apes, right? In order to better survive in their environment, the apes evolved from walking on 4 legs and living on trees to walking on 2 legs. And this was really the first emergence of humans as we know. And this was a pretty important step in our evolution, because moving from walking on all 4s to walking on 2 legs means that, our hands were freed and we could do things more efficiently. And this really helped us to, make things like make tools. And then that really helped us in becoming better hunters. It helps us, grabbing things. It helps us survive. And eventually we developed a lot of things. We developed things like agriculture. We developed languages, cultures, and all of those things. And eventually that led us to becoming the dominant life on our planet, right? And by dominant, I mean, we now have the power to change our environment to suit our needs, something that no other animal really has been able to achieve here on Earth. So we humans, passed through like all these various stages of evolution, starting from unicellular organisms to multicellular beings to, developing tools, cultures, agriculture, languages. We had things like the Industrial Revolution, we had the Scientific Revolution. So we passed through all of these various evolutionary stages over the course of our history. Now, the main question that I want to put forward to everyone is can we assume that life on other worlds also followed the same evolutionary stages? Did aliens also start off as unicellular organisms and evolve in the same way, or did they evolve in a different sort of way? So that is the question I'd like to put forward to everyone. And, this is what we will be doing in our breakout number 2, where we will be talking about all these evolutionary stages that we went through and trying to figure out which of these stages would be common to life anywhere in the universe. So the goal of this breakout will be to determine 7 stages of evolution that will be common to life anywhere in the universe. Okay, so Waden, I think we are all set to go into breakout number 2.
So I think all organisms would start from like a single cell and then slowly evolve into multicellular.
Okay, yeah. Single cell to multi-cell. Good.
Smaller creatures like
Like maybe like
Like small,
amphibians,
yeah.
rats, and okay.
Okay.
And then I guess from there they would get to bigger organisms, and then so over time they have to evolve to develop technology and be able to become advanced.
That's true. So you then, after the smaller organisms, you become bigger, and then you start getting intelligent and developing technologies. Okay. These are good answers. Keep going.
Yeah, can you guys think of maybe for the next one or two, maybe some that are kind of in our future of evolution, maybe?
Yeah.
And I guess eventually it might be possible to spread out to multiple planets, at least within the solar system.
Okay. Spacefaring to other planets. Yeah.
I think we're already at 6, right? Right?
Yeah.
We
One
already have
single
6
cell, multi-cell, small creatures, large organisms, tools and
creatures.
technology,
Mm-hmm.
and then
Planet
other planets.
colonizations. Wow, you guys are really good at this.
Like, do you guys think there's any of those steps that are particularly hard or more difficult than the other steps? Yeah, evolving to become intelligent. That's a good one. Yeah, I think that one seems like it might be a pretty rare trait
Yeah.
to evolve. So that's a good point.
I mean, we just discussed the Drake equation. That inherently makes it rare. So
So you guys think all the other steps are easy to achieve? Oh, Naomi says colonizing other planets and star systems.
oh yeah.
Yeah.
Especially since light is slow relative to the distances between different star systems. Even the closest one, Proxima Centauri, is 4 light years away. So trying to communicate with them, communications back and forth would take 8 years total. So and that's even if a signal would reach a planet, if the planet supported life at all.
What did we talk about during breakouts? Did we identify any possible evolutionary stages that could be common for life everywhere in the universe?
We first talk about like they all start being unicellular, then multicellular, and then they evolve to like a more complex organism. And also they like find a way to communicate with each other, and also a way to get food. And we also talked about technology like being part of one of the stages, but we finally conclude that not necessarily, because like living is just like eating, growing, and moving, and like technology, and it's just something that could happen and not necessarily part of the one of the stages.
Okay, great. What about the other group? What did we talk about?
Yeah, ours was actually our first like 4 or 5 steps were very similar. We said we had some other, our last 2 steps were like technology, and then we went on to like colonizing like planets and then stars and then even galaxies. I think we had as our very last step. Thought it was very interesting that Mariana brought up not developing intelligence necessarily. That was another thing we discussed. About any potential points that might be really hard for a civilization to achieve in their evolution. We said that evolving intelligence might be one that's very rare to evolve.
Interesting. It's really fascinating to me that you brought up the topic of, colonizing other planets and stuff, because that's exactly where I was going with this. And, I was prepared that maybe the students will not think of the future, but I was completely wrong. And yeah, you guys, great job in thinking about the future, right? Because humans, we're not really done evolving as of yet, where we are right now. We still have a long way to go in our future. So yeah, there are a lot of future evolutionary steps as well that, maybe we colonize other planets, eventually we colonizing, maybe moving to other galaxies as well. So yeah, those are some really, really great points. That really brings us to, what exactly is the great filter? We've been talking about the great filter, we mentioned it, but we haven't really talked about it. So let's actually say what the great filter is. So if we imagine the evolution of life as, a stairwell like this, and a lot of the various evolutionary stages, take up the various steps on the stairwell, right? So the idea of the great filter is that one of these steps is so difficult to achieve that most alien civilizations will never reach that stage. So what I'm going to do is I'm going to fill in all the stages that you guys talked about, right? So I think it is a common consensus that, life started off as unicellular beings, which then maybe evolved into multicellular organisms. And there's a lot of talk about intelligence. Some people think, life may not need intelligence in necessarily, but I believe someone mentioned communication, right? So humans in our evolution, we came up with various ways of communication. And until recently, we developed the internet, which is the fastest way to communicate with anyone across the globe. So, this is, I think, a really important point that we can add in our evolution. So I'm going to write, let's say, the internet. And maybe talking about the future, maybe we solve all our problems, like we solve global warming, we cure all diseases, So let's say, solve all problems, okay? And once we are able to solve all the problems, maybe we look to planets beyond Earth. So, colonize other planets. So I'm just going to write planets. And, once we have colonized all of other planets, we may move on to other stars, colonizing other stars, and maybe, colonizing other galaxies as well. So this is kind of a rough stairwell of evolution that we can all agree is common to life anywhere in the galaxy. So the concept of the great filter is that one of these stages is so difficult to achieve that most civilizations never get to it. So if we imagine the stairwell, let's say life starts off as unicellular beings, right, at the bottom of the stairs. And then, they evolve to multicellular, so, they make the jump to multicellular beings. Now, let's say the communication, or let's say the internet is a great filter. That means that it is really, really difficult for life to develop that sort of technologies. And so even though life may reach the second step of multicellular beings, they never go to the third step. They're never able to get to this third step. So if we look in our universe, we may find a lot of life that is multicellular complex, but no, or very few life that actually becomes develops that sort of technology to communicate effectively. So that is the idea of the great filter. So I would like to look at another example. So let's say if complex alien life is a great filter. So complex multicellular life, let's say if that is a great filter, then when we look in our galaxy, we will find a lot of planets with unicellular bacteria-covered planets. How many complex alien life do we expect to find? Any guesses? Not much, okay. Very few, okay. Not very much. So yeah, if complex life was a great filter, that means that getting to that stage of evolution is so difficult that almost no civilization ever gets to it. So that's exactly right. You would expect to find very few planets with complex multicellular alien life. So that is the big idea of the great filter, is that there's this stage that is so difficult to overcome that, no one gets to it. And that can really reduce the number of alien civilizations we find. It's hard to find planets that only have bacteria on them, right? It's hard to identify them. So it may be possible that when we look in our galaxy, we are seeing a lot of bacteria-covered planets, but we are finding no planets with intelligent life that we can communicate. So that is the idea of the great filter. And now I really want to open up the floor to all of you guys to, ask questions or tell us about the things that you found the most interesting in today's discussions. And, what stage do you think the great filter is, if it even exists? It may not even exist. So I would really love to hear all of your opinions now.
I think it is very interesting to have an equation to calculate how many intelligent civilizations there could be.
Okay. So yeah, that is the Drake equation, which kind of gives us an estimate of that. Okay, I see Naomi has a question. How do we know that life would evolve the same way we did or require the same conditions? That is a great question. I don't know if there is a very concrete way to determine how life may evolve, which is why I think for now all we can do is make assumptions. And that's why that was kind of like the idea of this stairwell, that we made assumptions and we said we can assume that all these stages would be common to life elsewhere. So we can't say with certainty, but this is our assumption. We are saying that we assume that these stages are common for life anywhere. That's a great question.
Somebody brought up the idea that the rate at which life might evolve could vary greatly, and how long civilizations might exist, even life itself, never mind civilizations. I did a quick calculation. The estimate for when life originated on Earth is about 3.5 billion years ago. So you trace back for 3.5 billion years. If anybody had been trying to contact us, by anybody I mean an alien civilization, they would have to have waited 3.5 billion years to know that life existed here. And in that 3.5 billion year time, we only developed radio signals about 120 years ago. And that's about 10 to the minus 6, or a millionth of a percent of all the time life existed. So it's kind of intriguing for me to think about, there could be life out there that we would have no way of contacting because they don't have a way to contact us back.
Yes, this is really interesting idea of, there being an intelligent alien civilization that is so far advanced that their method of communication would be vastly different than our own. And, we would never be able to identify their signals that they send, basically. And vice versa, let's say right now we are sending out radio signals in the space around us. But if there is a planet, which is covered by bacteria or very primitive sort of life that has no way of really recognizing those radio signals, then there's no way to communicate. So that is a really interesting point that you bring up there, is that how much this time difference is there between a civilization sending out their sort of communication and the other end receiving it, and how technology evolves in time. So that is a really interesting point that you bring up, Dave. There are a lot of other interesting things about the great filter that we didn't have the time to get to, that I would have loved to talk about, but it is a really interesting topic. Before we leave, I really want to thank a lot of people. I want to thank, firstly, Dr. David Cederberg, for helping me develop this topic and giving me very crucial feedback on how to present this and all that stuff. So thank you, Dave. I couldn't have done it without you. I'd like to thank all the TAs present here, for taking a time out on this Saturday morning to come here and have this really interesting discussion. And finally, I want to thank all of the students and who are present here. I really, really, really appreciate all of your participation. And yeah, we could not have done it without you. So thank you so much for being here to, have this discussion of life on other planets and aliens and all that interesting stuff. So thanks a lot.